Alright, you guys, I'm gonna post a video here for people that were absent. We've had some people sick, out of town, whatnot, and also some people that were even in class. We kind of got cut short and we're a little rushed with the assembly today. So I'm gonna try to get through these notes as quickly as I can. Please feel free to pause, rewind, fast forward based on what you saw in class. If anything, like I said, some people were not here. And rewatch anything you need to rewatch. So let's go ahead and start from the top. Once I get my pencil sharpened. All right, so today we talked about some relationships between sine, cosine, and tangent. The first relationship we talked about was the Pythagorean identity. The Pythagorean identity, and we talked about this in actually chapter 1, is that sine squared plus cosine squared equals 1. Now if we just wrote it like that, it doesn't really make much sense because we always have to take sine of an angle. In this case, we use the variable t, we've seen a lot this chapter, to represent an angle in radians. So sine squared of t plus cosine squared of t equals 1. And again, this holds true for every value of t. If you want to test it out, plug in any angle that you know. Sine of, let's say, pi radians. We'll have t be pi. So sine of pi we know is 0. 0 squared is 0. Cosine of pi is -1. -1 squared is 1. And sure enough, 0 plus 1 is 1. So test it for any angle and it should work out. The next relationship that we talked about was tangent. Tangent of any angle, so we say tangent of t, is always equal to the sine of that same angle divided by the cosine of that same angle. And again, this works for every value of t. Alright, so we're going to use these two identities. We're also going to use our definitions of sine, cosine, tangent, so just SOHCAHTOA, and our knowledge of angles in standard position to complete these notes. Keep in mind angles in standard position are angles that start on the positive x-axis. Okay. If they're positive, they go counterclockwise. If they're negative, they move clockwise. Angles that end in quadrant 1, so again, if their initial side is here and they end in quadrant 1, we can simply draw in the terminal side. Okay. So that would be t radians. That's what it means to travel t radians. We can take that point, we can drop it down to the x-axis, and we can find all three sides to find the sine, cosine, tangent. Keep in mind that on the unit circle is the only circle where the coordinates of that point are x and y, because cosine is adjacent over hypotenuse, and the hypotenuse of the unit circle is always 1. So that's why cosine is always your x-coordinate on your unit circle. Sine is opposite over hypotenuse. This is a whole nother video. I'm kind of off on a tangent right now. Sorry about that. But keep in mind that if we travel in standard position to any other angle, so say you traveled t radians took you all the way into this quadrant. You ended here. This was your terminal side, so your angle was clearly over pi over 2 radians. You can still take that point, drop down to the x-axis. Okay, if we thought about it in terms of angles, this is your reference angle theta. That's your angle. Your reference angle theta primed is right here, and you can still find your hypotenuse. So if it says is, but it should be if. Also, excuse my nail polish. I need to do a manicure here. If it's possible for a number t, so any angle in radians, to satisfy the given conditions. Satisfy means make it true. So can sine of some angle equal -1 and cosine of that same angle equal +1? Well, if there's a value that, or an angle that we could take the sine of and get -1 and take the cosine of and get 1, it should make the Pythagorean identity true. So to test this, we're going to see if when we take sine and we square it, so sine of t is, they're saying, is -1. When we square that, and if we add it to cosine squared t, which is cosine of t is 1, and we square it, We always know that sine squared plus cosine squared equals 1, so basically do these two still equal 1. And in this case, we can clearly see they don't. Negative 1 squared is 1, positive 1 squared is 1. This side equals 2. So in this case, sine squared plus cosine squared equals 2. It doesn't equal 1. So in this case, what we say is we say no, there is no value of t that would satisfy this condition. No value of t will satisfy, or make true basically, satisfy this one that I circled, condition, or these two conditions, sine and cosine equaling these values. So on the next one, let's go ahead and do it the same way. They gave us sine, they gave us cosine squared, so let's test it. Does sine squared, so if we square, so sine squared, here I'll write it out, sine squared plus cosine squared, I promised I'd get through this quickly. We know it always has to equal 1, so if we plug in these values and we get it to equal 1, then we know we're good to go. So if we square this guy, and we add it to the square of cosine, or the cosine value that they give us, will this equal 1? So 1 times 1 is 1. Square root of 2 times square root of 2 is just 2. Again, with fractions, you multiply top with top, bottom with bottom. Negative 1 squared is 1. Square root of 2 times square root of 2 is 2. Yes, 1 plus 1 does equal, or 1/2 plus 1/2 does equal 1. So the Pythagorean identity, we know is always true. When we plugged in these values, it made the expression equal 1. So sine squared plus cosine squared was 1. So therefore, there is an angle. In this case, since sine's positive and cosine's negative, I know that my angle has to be somewhere in quadrant 2. That's the only place where sine's positive and cosine's negative. There's some radian measure, t, some number of radians that we can travel that will start in standard position, rotate here, or if t was negative, we could go in this direction. But in this case, that somewhere ends here, that where sine is this value and cosine is this value. So in this case, we say, yes, there is a value of t that satisfies this condition. It didn't ask us to find the value that satisfies, it just said determine if it's possible, satisfies this condition. So in this one, yes, it's possible to have a value of t that satisfies. All right, in the next example, all right, we're 7 minutes in, still a little longer than I wanted, but like I said, today's class period, so it was about 20 minutes, it felt like. So given the following information, find sine of t and tangent of t. Well, the information that they gave us two facts. They gave us cosine was negative 3 over root 2, so that means cosine's negative, so it has to end in quadrant 2 or quadrant 3. But they also told us that t, that radian measure, was between pi over 2 and pi. So in this case, we recognize that our angle does, we drew a picture of this here, it ends, t radian ends somewhere between pi over 2 and pi. So somewhere in this quadrant. So I did this 2 different ways in class. I'm going to do it 2 different ways in this video. I'm going to end with this example, let you guys try this one on your own. The first way we can do it is picture a side, do this with just pure algebra. So in this case, if you know cosine and you're trying to find sine and tangent, well, the first one that we need to find is sine, because we know the relationship between sine and cosine. And where do we know it? Thanks to the Pythagorean identity. We know that sine squared plus cosine squared equals 1, so if you know cosine, you can find sine. If you know sine, you can find cosine. So let's go ahead and find sine first. So in this case, we know that sine squared plus cosine squared equals 1. So let's plug in cosine. So this is going to be negative 3 over root 10 squared. We're trying to solve for sine. So if we square this, negative 3 times negative 3 is 9. Square root of 10 times square root of 10 is 10. This is just now some algebra. I'm not going to put that over 1 because I don't need to add them. But I'm going to subtract 9/10. So 1 whole minus 9/10 is like 10/10 minus 9/10, which is 1/10. So sine squared t equals 1/10. take the square root. Now technically it would equal plus and minus, but because we just talked about how t ends in quadrant 2, you know sign has to be positive in quadrant 2. So therefore you know that it has to be positive. In this case we'd get square root of 1 is 1, square root of 10 is square root of 10. And if we rationalize it here, we get square root of 10 over 10. Not really good practice to have two equal signs, don't really like that. But here we'll rewrite this. So we know that sine of t equals root 10 over 10. Halfway there, they also want us to figure out tangent. Well, the good news is, guys, with our other relationship, we know that tangent can be defined as sine over cosine. So in this case, I use this identity to find sine. I'm going to use the fact that tangent equals sine divided by cosine to figure out tangent. So tangent is sine, which is root 10 over 10. I'm going to put the division sign here just for a reason, divided by cosine. So I'm writing it like this instead of over because I'm dealing with fractions. Cosine is the one that they gave us, negative 3 over root 10. And with division of fractions is as easy as pi. You flip the second, basically write the reciprocal, and multiply. So division is multiplying by the reciprocal. So, sorry, we're running out of room. So tangent is square root of 10 times square root of 10, which is just 10. And then 10 times negative 3 is negative 30. So 10 over negative 30 is 1/3. So tangent of t equals negative 1/3. Okay. Again, it was, sorry, I didn't write out all my work, but square root of 10 times square root of 10 was 10. 10 times negative 3 is negative 30. So this reduces to 1/3. Doesn't matter if the negative's on top or bottom. All right, the second way, and the way that I like doing it, well, I prefer sometimes for students to do it the way that I'm going to do it right now, is just because there's less algebra involved. Okay, now you guys are all capable and a lot of us need some practice, but may not be our strength. So I suggest you definitely know how to use the algebra to solve problems like this, but I'll show you another, I think, nicer way to do a problem like this. So in this case, if I draw a picture, keep in mind they told us the cosine of t was negative root 3 over 10. So this means that the ratio of the adjacent side divided by the hypotenuse was this value. It doesn't mean the adjacent side is negative 3 and the hypotenuse is negative 10, but by no means does it prevent us from drawing a triangle where we have the adjacent side equal negative 3 and the hypotenuse equal square root of 10. That's just one possible triangle we could draw. So the good news is we can actually draw that triangle in our circle here. And knowing that our angle ends in quadrant 2, we talked about that because it was between pi over 2 and pi, you can just move that triangle and draw it, again, t radians, what goes from here. We don't know exactly where it ends. You don't even have to draw it to scale for problems like this if you're just trying to find ratios, sine and tangent. So in this case, I'm just going to randomly end in quadrant 2 anywhere, and we can draw in an angle. Okay, and in this case, cosine of that angle, even though, like I said, it's t radians, if we thought about it in degrees, it's so and so many degrees, we'd use our reference angle since it's ending in quadrant 2. So we have cosine's adjacent over hypotenuse, so we're actually going to make our adjacent side negative 3, and we're going to make our hypotenuse negative 10. Nothing's stopping us because they didn't tell us what sine or tangent is. And in this case, we can just use Pythagorean theorem, a squared plus b squared equals c squared, to find this missing side. So a is just one of the legs. The only a I know is or the only leg I know is negative 3, so I'll just go ahead and make that a. But I could make it b if I wanted to, it doesn't matter. Oh, and it's c squared. What am I doing? Sorry, I'm a step ahead. A squared plus b squared equals c squared. But we know that c is square root of 10. So negative 3 squared is 9. Square root of 10 squared is 10. Subtract 9. Take the square root. So b could equal positive or negative 1. But since we're in quadrant 2 and we're finding our vertical side here, we know that B has to equal positive 1 only. So in this case, we have our triangle complete. So now if I asked you, or it does ask us to find sine and tangent, the nice thing is we have a triangle. We have all three sides. We can find any trig function they want us to. So they gave us this one. Sine is just opposite over hypotenuse. 1 over root 10, though, we talked about if we rationalize it, would be root 10 over 10. And tangent is opposite divided by adjacent, so 1 over negative 3 is negative 1/3. Exact same answers that we got with all this algebra. So just to verify that, hey, the algebra works, the picture works, and for this problem, which way do I want you to do it? Well, I'd like you to be able to do it both ways. If you feel comfortable with this way, maybe start with this way, merge into this way, see if you can get the answers to match up. This video is quite long. On the back side, I want you to do these 4 problems on the back. We'll go over the answers on Monday. We're also going to do this example in class on Monday. You can actually get started on this because basically this is the same thing. They gave you sine, they gave you where t ends, in this case it's quadrant 1, and they ask you to find a huge list of things, but keep in mind, look at some of this we've already done. If you have sine, you can find cosine, draw the picture or do the algebra. If you have sine and cosine, you can find tangent. And if you use a little bit of sense making for the other ones, in this case it's saying what's the cosine of negative t radians? That just means if you go in the opposite direction, what would be the cosine of that angle? And if you look at your unit circle, just I'm kind of hinting towards some things, but for example, if you look on your unit circle, there's some symmetry that goes on. If you travel, let's say, 45 degrees, and this is only on the unit circle, will the x-coordinate be root 2, but we know that the cosine's root 2 over 2. Well, if we traveled negative 45 degrees, we see that cosine is still root 2 over 2. So cosine stays the same. If they asked us to find the sine of 45 degrees, well, sine of 45 degrees is positive root 2 over 2. So what's the sine of negative 45 degrees? Well, in this case, it takes us to the opposite quadrant, where in this case, it's not the exact same, it's just the opposite, because the y-coordinates are opposite in these quadrants. So, anyhow, we'll touch more on this Monday. I'm kind of getting ahead of myself, but see what you can do. Continue to work on, learning your unit circle, practicing all the reviews that I've been giving you guys. Come in and check your answers in the morning or at lunch, after school. I'm available. Like I said, these are our notes, so we're gonna finish our notes on Monday. Just don't panic. Hopefully some of these parts are kind of coming together. What we did on this worksheet here with drawing the picture, this example here, we did that on the standard angles position worksheet, just in a little bit different sense. Instead of giving us a ratio, they told us a point that the angle goes through. We drew our triangle and found missing trig functions. So anyhow, our final will mainly be over this and chapter 1, since those were the 2 trig chapters this semester. Chapter 0 was kind of getting us ready for some concepts. For example, factoring was something that we saw back in chapter 0 that we're seeing now in chapter 2. So the focus of the final exam will be this material, which we're testing over on block day, and chapter 1, which was a lot of things getting us ready for this chapter. Chapter 1 was getting us ready just with basic sine, cosine, tangent. So you're going to find that, oh, chapter 1 stuff we've been using all along. So we're just kind of putting all the pieces together. So stay positive, continue to ask your questions, don't panic. Stress doesn't help anything. So anyhow, have a great weekend, you guys, and I will see you on Monday.